Okay, this is Mr. Peterson, and I'm going to guide you through the review for the Part A section of 1.5 and the Part C section of 1.5. There's going to be two other sections that you'll review next class period. It's my intent that you view a few problems and then do a few problems on your homework, and I will alert you to when you should make that transition. So stay tuned, and here we go. Okay, for the first few problems here, what you're supposed to do is take a point that's given to you. In this example, it's the 0.63, and see if it's a solution among many millions there could be to the system of equations. So we'll start by working with the first equation, and you can see that I plugged the value of 6 in for x and 3 in for y because that's what we were given. You do the calculations there, and you get a true statement, 3 equals 3. Then you proceed on the other, first of all, I'm going to just show you the how to multiply 2/3 times 6 because that may trip some of you up. 6 can be thought of as 6 over 1, and if you think of it that way, the bottom of the 2/3 is being multiplied by 1. In other words, you don't mess with that 3 on the bottom. So what you can do here is simply take the whole number times the top, which would be 12, and then divide by the bottom number, 3, to get your answer of 4, and that's how I got that 4. Okay, now we've established that the first equation, y equals 2/3 x minus 1, turns out to give a true statement with our test 0.63. Now we're going to do the same on the other side. Once again, we plug in 6 for x and 3 for y, and we get another true statement. These happen to be the same true statement both times, but no matter, you get a true statement both times, which means it is a solution. Okay, another example just like this. The first thing we're going to do here is plug in this new point, -3, -7, in for the x and y values. Pay attention, make sure you get the x where it says x and the y where it says y. And working that out gives a statement of 9 equaling 9, which is definitely true. But when we plug those same numbers, -3 for x and -7 for y, you'll notice that those are kind of in reverse order there. The y is in front. You get -29 equals -26. That's a false statement, and you conclude that that point is not a solution. So here would be a good time to pause and do the first two problems on your homework. Then you'll come back to the video. Okay, assuming you paused the video like you were supposed to and now you're back, we're going to start another series of problems where you're going to be solving by graphing. In this first example here, we have a y-intercept of 4, so let me write that, and a slope of 3 rise, 4 run. So you count 3 units up and 4 units over, and step it off like that, 3 units up and 4 units over, and then down 3 and back 4, down 3 and back 4, down 3 and back 4. Okay. Once you got that done, you're going to draw a precise line through that point. Let me get it set up here. Yeah, it looks like I got what I want here. And once you get that line drawn through there, let me finish by putting those arrowheads on there like you're supposed to. I'm going to draw another line, and I guess I can make this one green here, with a y-intercept of -1 and a slope of -1 means down 1 and to the right 2. So go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, and down 1 over 2. Now I'm going to point out that that's interpreting the negative sign as going with the rise. But this is also the same number, which means we go up 1 and back 2, up 1 and back 2. By the way, there's your solutions, the place where these cross. And you paste this off here and draw that line. Okay, let me get that line drawn through there. Now that's kind of faint, but I think you can see it. And finish by putting our little arrowheads on the ends. And then I simply count out this solution point right here. And the answer is going to be, hang on, let me get this set up here. The answer is going to be the point -4, 1. And you count out from the origin. There's the origin. 4 backwards and 1 up to get to that point of intersection. So there's the solution to that system of equations. Okay, so here's another example of this. We're going to, first of all, rearrange, get the y by itself. So you can see I first of all took the x over the other side and made it -x, and then divided everything by -4. And once that's happened, you can find this y-intercept of 4 and put it on your graph there. And your slope is 1 up and 4 to the right. So I'll count that up. Count that out. 1 up, 4 to the right, 1 up, 4 to the right, and then I go back the other direction. And I'll draw my line through there. Let me get a little thicker line this time. So, all right, that's, for some reason I got some transparency issues going on there. And I'll get that straightened out. I think you can see it anyways there. So there we go. Now I'm going to draw the other line, and you got to rearrange its equation. So first of all, you take the 2x over the other side, and the only tricky part of this is interpreting the slope. 2 down, and the default run is always 1 over. So I'm going to find the y-intercept of -5. And I go 2 down, 1 over, 2 down, 1 over. And once I'm done with that, I'm going to go up and back in the same pattern. There's our answer, by the way. So this thing goes all the way down through there. And get it lined up a little better. And the place where these intersect is the solution, which in this case is 4 back from the origin and 3 up. So -4, 3 is our solution. Okay, on this problem, let me first of all solve for y, and I'll graph that one. So that one hits at 3, and it's got a slope of 3 rise, 4 run, 3 rise, 4 run. And if you go down and back, that would be like -3 and -4, which is still the same value. -3 over -4 is a negative over negative, also gives a positive. So here we go. There's our line. I always have to rearrange where it ends up here on my tools. And I can put my arrowheads on there. Let me make that a little neater. Okay. Now the other one, once we solve for y on both of these equations, gives a y-intercept of -3. And this one has a slope of 3 up and 4 over, 3 up and 4 over, 3 down and 4 back, 3 down and 4 back. And we have an issue here, Houston. These lines don't intersect. They are parallel to each other, which one of the ways of telling parallel lines is that they don't actually cross each other. So you're going to put this system is inconsistent. And these type have no solution. That's what you put in this situation. Okay, I'll show you the other exceptional one, the one that causes issues. We got one that's ready to graph up here, so I'm going to go ahead and find my y-intercept of 3 and go 2 down and 5 to the right, 2 down and 5 to the right, and then I'll finish it off going the other direction and draw my line through there. that is the first line. And then if I solve for y over here, what you notice here, if you look carefully, that this line down here and this line up here are really the same line twice. What we have is concurrent lines. And the way you indicate that on paper is you just do a double set of arrowheads here, meaning both lines, one line's on top of the other one. So the places, the number of places they hit is an infinite number of places. So here's the way you answer this. You say dependent. That's what we call these systems. Dependent. And infinitely, you can abbreviate like this. Many, and then solutions with an S on the end, you can abbreviate that way. So this is how you answer your problem when that type shows up. Okay, at this point, you're going to do a pretty long pause. You got to do problems 3 through 8 on your homework before you return to this video. And when you return, we'll continue. Okay, welcome back. You guys have finished problems 3 through 8, and now I'm going to show you some examples for the next section. So, first thing I wanted to point out here is that we have inequalities, greater than signs and less than signs. And that means you're going to be shading on one side of the line, since any y value that's bigger than the y values on the line will be above the line. Now I'm going to give you a little chart later that'll show you all the different possibilities here, but for now I'm just going to tell you that when y is greater than, you're going to use a dashed border and you'll shade above the line. So first of all, let's find the y-intercept. And then we go 2 up and 3 over, 2 up and 3 over. We'll be drawing a dashed line through here. So let me set that up. And let me see if I can get this to show up a little darker this time. Yeah, that worked better. Okay, there's our first line. And eventually we want all of our points to have y values that are greater than the y values on this line, and y gets bigger as you go up. So we want to shade above that line, and you make that little note on there for later use, above. Okay, the next line is solid and above, and what makes it solid is it has the or equal to, and that is the one that actually generates the line like the previous parts on this video where we had equal signs. So let's find the y-intercept of 3. And this time the slope is 1 down and 2 to the right. You can also go 1 up and 2 to the left, and that's because this and this are equal. Either you rise downwards and go to the right, or you go upwards and to the left, and those are the same thing. So that's why you do it that way. Now this time I got to draw a solid line, and maybe you could see me picking the solid option on my drawing tool there. And there it is. And we need to be above that one. And to be above both of them, you need to shade the area that's up here. Now, if you're using a pencil and don't have a highlighter, then I will show you how to crosshatch this. So let me simulate using a pencil. Now, if you have a number 2 pencil, just turn it sideways and do that shading. If you have a mechanical pencil, you're just going to just cross hatch this like this neatly. And that does it for that problem. Okay, let me do a few more like this. A little chart here to help you out, okay? So the first thing here is the ones that don't have the or equal to, you use dash borders. If it has the or equal to, you use solid borders. And since the y measures up and down, greater than ones are above and less than ones are below. Now, the only time I don't ask you above or below is when it's a vertical line that only has x's. X doesn't measure up and down, it measures left and right. And in that case, since x gets smaller to the left, less than you want to shade to the left, and greater than gets shaded to the right. So you might have to take a picture of that before you move on. So pause and do so if that's helpful information to put on your phone. And we're going to go on to a few more problems like this. Okay, the first one we have here starts out with 2x plus 3y is less than or equal to 18. So you're going to solve for y, and I will warn you that you don't decide the shading direction above or below until you're done getting the y by itself. So you notice that I finally highlighted y is less than or equal to at the very end. Okay, let's get this drawn. This is a y-intercept of 6, and the slope is 2 down for every 3 to the right. 2 up, 3 back, 2 up, 3 back, and we're going to draw a solid line here. All right, once I get this line in place, and let me do a better job of that. Put my arrowheads on it. I'm going to label it below. So in your mind's eye, don't do this on paper, you know that you will not put any shading up there. That up there is never going to be shaded at all. Okay? I don't want you to actually do that on paper. Just label it below. You have to be below that line. Now, as these get steeper, people have trouble sometimes with above and below. So what I usually suggest is put your pen on one of the points, and below would be downwards, and it tells you where you eventually will be shading. Okay, let's do the other one, and I'll uncover some of that work. You'll see why I told you earlier to decide on the direction of shading at the very end. If you look up until this point, the greater than sign ruled. It was greater than sign for a couple lines, but dividing by that -1 turned it around, and that's why you have to wait until the end to decide. So we're going to be dashed in below that line. So always decide at the end of getting the y by itself rather than the beginning. All right, so this one hits down here at -4. And the y-intercept, the slope is 3, which means you go up 3 and the default is 1 run. So 3 up and 1 over, 3 up and 1 over, 3 up and 1 over. And we'll step that out in the other direction. We're drawing a dashed line this time. And we're supposed to be below that line. So I'll write that in there, below this line. Well, the only part that's below both lines, our solution set, is this part here, below that line and below this line. And it's this section right here. So colored in, or if you're doing the hash direction version of it with a pen, or hopefully not a pen actually, or a pencil, a mechanical pencil, you're going to go like this. Now, if you got a number 2 pencil, just turn the lead sideways and do some nice, beautiful, artistic shading on this. I'm not doing a very good job. Let it back up here. Try to keep it neat. I'm having a little difficulty on this computer. Okay, so let me back up and show you how you could identify which corner um, would be the corner to use. So if I back up, you're trying to decide where does the shading go. So I'm cleaning all this up here. All right, so you're at this point, and what you can do as soon as you write this below, you can make two little X marks there below it. And then when you're, say, below the other one, you can make one on each end, a little X on both ends. And the section right here that has two X marks will be the part that gets shaded. So you just pick up your marker and start shading it. And I'm just going to use crosshatches to shade this one. Here's what it would look like if you did it with just crosshatching. And this time it looks like I've done a little better job at it than last time. Okay, I've got two more before I turn you loose on some more homework problems. You can see that I've got these two ready to go, and I've labeled them. I've also got them pictured. What I'm going to show you here is that to be, well, above the dashed line would put you right here or right here. And to be below the other one would put you right here and right here. So it is entirely possible to be in that section. You can be above one and below the other. And the section that works is this section right here in between them. So you gently shade that. And that whole green section, light turquoise greenish section there, those are millions and millions of points that are above the dotted line and below the other one, so they qualify. So unlike the parallel lines problem that we had before where we were looking for a single point where these lines crossed, here this actually has a solution. So don't write what you might be tempted to write, which would be inconsistent and no solution. This one has millions of solutions. Okay, so I've got one of the lines drawn already here, and I've got it all worked out. You can see we're supposed to be above that line there. And I'm going to turn your attention at this point to the second line here, this one. When it has just a Y in it, it's a horizontal line, and it doesn't have the or equal to. So I'm going to go up 4 spaces up, and I'm going to find a bunch of points that are 4 up. And quickly you see the pattern here. It's going to be a horizontal line up there, 4 up. Let me pick the right color here. And let's go. All right, so I'm going to draw that horizontal line up there. And I'm supposed to be below that line. Y is less than will make me below that line. So if I paused right there, let me see if I can draw this a little better. Below. There we go. If I stopped right there, it would be in this little wedge over here. But we have one more constraint. The x has to be greater than or equal to -2. And the x's that equal -2, there's the most obvious one to most of my students. But we're 2 to the left there, 2 to the left there, 2 to the left up there. It doesn't take long to realize that's a vertical line. So we can draw a solid line back there. And I don't think I have it in the right position here. I'll have to reposition a little bit. There we go. All right, let me get the arrowheads on it. And x is greater than, x gets bigger to the right, so we have to be to the right of that line. So that traps us in a very tiny area here. We have to be above this diagonal solid line, below the dashed line, and to the right of the other line. So it puts us in that little tiny area right there, which incidentally does have millions of points in it too. So we still have millions of answers. Okay, you are set up to do some more of your homework, so it's time to complete numbers 9, 10, and 11. I don't know if I skipped any there, but you got to get done through 11. So pause it and come back. Okay, you paused the video and you're back, and that's good. And we're going to graph this one. It's got a diagonal line. Maybe you can see that this one has an X and a Y in it, so that means we're dealing with a diagonal line. We've done millions of those, so let's go ahead and find the y-intercept of 2 and count out a slope of 2/5. We'll draw a dashed line through there. Put the arrowheads on it. And label that, I'm looking right here when I say this, below. We have to be below that line when we shade. So you now know that this area up here will be white when you're done. Okay, then we have a vertical line at -2. This is the same line we drew 2 to the left. Here's the x values that are -2. Here's the one most people think of. And you see we have a vertical line going here. The x equals equations always yield vertical lines. It's confusing to students because that's the opposite of the direction of the x-axis. Okay, so there we go. And I'll get that arrowhead drawn on there. Those arrowheads. This is to the right. I don't think I got that quite centered. Let me get my pointer out here and get that thing just a little bit more to the left. Okay, that'll do. Okay, we have to be to the left of that line. So I'm going to label that before I forget. We have to be to the left of that line. Here's what tells me that, less than. Okay, the last one here is a parabola. It's got an x squared in it, or an x plus 3 squared to be precise. And that squaring action right there gives it the U shape that we're, roughly speaking, a U shape. It's a parabolic equation. So I'm going to start with finding the center, and I've already got this set up, but you need to know how to do it yourself. So I'm going to come over here and show you how you do it. The part that's being squared, set that equal to 0 and solve for x, and that'll tell you the middle value of your table of values. It tells you the turning point, which is called the vertex. Okay, from there you go 3 larger and 3 smaller, so you branch out 3 on each side. I require 7 points if you can fit them. So let's start with the vertex itself. -3 is our x value. -3 plus 3 is 0. 0 squared is 0, and 0 minus 8 is -8. So here is the vertex. This parabola turns around right there. Now the next two, one on each side, should be matching. You're going to check by doing them both. So we're going to plug this -2 in. -2 plus 3 is 1. 1 times itself is still 1. 1 minus 8 is -7. So I've plotted that point already. Now we should get the same value here, but you want to check. Okay, -4 plus 3 is -1. -1 times itself is +1. 1 minus 8 is -7. And sure enough, matching heights. -7 on both of them. Now you're going to take full advantage of that. You're going to find this one and simply copy it up here. So, -1 plus 3 is 2. 2 squared is 4. 4 minus 8 is -4. All right, we got one more pair to do. We'll plug 0 in and then copy it up here, or the other way around. So maybe let's do it that way. Okay, -6. We're going to put that in. -6 plus 3 is -3. -3 times itself is 9. 9 minus 8 is 1. Let me get that right. So 0, 1 and -6, 1. Okay, so we're drawing a solid border there. Do your best. These are hard to draw. Yeah, I missed. Okay. Maybe it'll be good for you to see that your teacher has struggles with these a little bit too. Okay, and we're supposed to be, if you look over here, above that border. So we have to be below the dash line, to the left of the vertical line, and above the parabola. So here's your solution set. It's all the points that are in this area here, and you got to be careful to stay to the left of that vertical line. And that does it for that problem. Okay, I got like two more here. Okay, here's one with an absolute value, but first let's get the top one out of the way. Horizontal line at 1, solid and shaded above. So horizontal line up at 1. I chose the solid dash instead of dash because of the or equal to over here. And I have to be above that because it says y is greater than. Okay, so I know I'll have no shading on the bottom half of that graph. Okay, now just like the ones with squares in them, these ones with absolute value, you bring the part that's inside the absolute value off to the side, set it equal to 0, and it'll tell you x equals 2 should be the vertex. So I'll label it vertex. Now, unlike the squaring, this absolute value does something different. All it does is force negatives to be positive and leaves positives alone. So we're going to put 2 in first of all. 2 minus 2 is 0. The positive version of 0 is still 0. 0 times negative 1/2 is still 0. 0 plus 4 is 4. So 2, 4 is your vertex point. Okay, now let's plug in 3, and we'll do 1 later, and they should match. So we're going to try those. First 3. 3 minus 2 is 1. The positive version of 1 is still 1. 1 times negative 1/2 is negative 1/2. Plus 4 is 3.5. Okay, now I'm going to plug in 1. 1 minus 2 is negative 1. The positive version of negative 1 is 1. That's the absolute value reaction. 1 times negative 1/2 is negative 1/2. Plus 4 is 3.5. And there's the confirmation that we've done everything right so far. Let's see if I can get that to look like 3.5 there. Okay, there we go. So that's right here. Okay? All right, now I'm going to plug in 4, and I'll fill in 0. 4 minus 2 is 2. The absolute value of 2 is still 2. 2 times negative 1/2 is negative 1. Plus 4 is 3. So we're down to there and there. And I'm going to plug in 5. 5 minus 2 is 3. Absolute value of 3 is still 3. 3 times negative 1/2 is negative 1.5. Negative 1.5 plus 4 is 2.5. And you can see we've got a V going on here. And that's the shape you should always get. Okay, it does have the greater than, but no or equal to, so we want to make sure I used a dash border. And put my arrowheads on there. And we're supposed to be above that. So I'll write above that. So to qualify as a solution, you got to be above the horizontal line and also at the same time above that V. So let me draw the outline of our answer here. It's going to come along this way, and it has to stay up there, stay above both the V and the solid line, and come back down, and then we're going to cross hatch it or fill it in here, either one. And I did a pretty sloppy job there. Let me make it a little neater because you want to be proud of your work. And I think I can be proud of that. That looks decent. Okay, now if you're doing the crosshatch method, just start over here and you'll notice I'm starting right on the border and going that way with it. It helps if you put your pen right on the border as you do it, okay? It's a little harder to do a neat job this way, but there you go, the idea, okay? So, one more problem here and we'll be done with this video. What I just wanted to show you here is a case where, well, you really don't have an answer, okay? We're supposed to be, we have a diagonal line here, and that's the first one. We're supposed to be below that one. So if you can see the purple dots down there, those would qualify if that's the only thing we had. You have to be below that dashed line down there, okay? And then I've got a parabola, and it's already graphed here, but you're supposed to be above that one. So if you think about the pink ones, they're above the parabola, but they're not below the other one. And the purple ones are below the dashed line, but they're not above the parabola. And the green ones just simply don't qualify. So let me show you again. The pink dots are above the parabola, but they're supposed to be below the other line, and they aren't. So I'm going to erase those. And the purple ones are definitely below the diagonal line, but they're not above the parabola. So we're going to erase those because they don't work. And the green ones are not, they don't qualify in either one of them. They're not above the parabola or below. So they don't work either. And this is a situation where you have no solution. And you would just write that. Okay, that does it for our video. I know it's 40 minutes long, and you're going to struggle to get through all this, but get 12 through 14 done. There's 3 problems there. All right, signing out, Mr. Peterson. Bye-bye.